In this video, we're going to finish up the three last problems of the algebra of complex numbers. So we're going to write each one of these three in the form a plus bi, or a plus ib if you prefer. So let's start with number 3, which I have rewritten here. So what we have is a fraction, a complex number over a complex number, minus another complex number over a complex number. And what I'm going to do is I'm going to convert this fraction, I'm going to simplify it and write it as in the form of a plus bi. And then I'm going to do the same thing with this one. And then it'll be a simple subtraction problem. So what we have here is, in order to do that, I'm going to take this fraction and multiply top and bottom by the complex conjugate of the bottom. Well, the complex conjugate of 3 minus 4i is 3 plus 4i. So I'm going to multiply top and bottom by 3 plus 4i. And I'll do the same with the second fraction if I have enough room here. We've got 4 minus 3i over 2 minus I. I'm going to multiply top and bottom by the complex conjugate of the bottom. The complex conjugate of 2 minus I is 2 plus I. Like that. The beauty of multiplying a number by its complex conjugate is that you're going to get a real number out of all of this. So I'll let you convince yourself of foiling that out, but you'll notice that the outer and inner will cancel. The outer and inner will cancel. And what you end up getting is, let me foil out the top first. Looks like I will get 3 plus 4i plus 6i is plus 10i plus, the last is going to be plus 8i squared. Now we know that plus 8i squared is really minus 8, but the bottom is beautiful. We get 3 squared plus 4 squared. That's the beauty of multiplying complex conjugate pairs together. Square the first, the real part, square the imaginary part from either one of these because you're squaring it. 3 squared and 4 squared, 3 squared and 4 squared gives you 25. Minus, let's FOIL out the top. 4 times 2 is 8. Then we have 4i minus 6i. 4i minus 6i is minus 2i. And the last is minus 3i squared. Once again, that's going to be a positive 3 because I squared is negative 1. Okay, 2 squared plus 1 squared is 5. And once again, if you want, you can FOIL that out and verify that you get a 5. So this will be equal to, this is a negative 8 right here. Negative 8 and 3 is negative 5 plus 10i over 25 minus, this is a positive 3. 3 plus 8 is 11. Minus 2i over 5. Well, to get a common denominator, actually I was going to get 25, but this can simplify. If I divide the top by 5 and divide the bottom by 5, I would get negative 1 plus 2i over 5 minus 11 minus 2i over 5. So I seem to be running out of room, so I'm going to finish this up with one more step. Remember, there are implied parentheses around every numerator and denominator, so I'm going to get negative 1 minus 11, which is negative 12. I'm combining the like terms in the numerator. And then I have a 2i minus a negative 2i. That's 2i plus 2i And to write this in the proper form, this is very close because we're dividing it by a real number, but let's make that negative 12 over 5 plus 4 over 5i. So this difference of this is a division problem, the top divided by the bottom, minus the top complex number divided by the bottom, simplifies to negative 12 fifths plus 4 fifths I. Negative 12 fifths is our real part of this complex number. 4 fifths is, that's positive. 4 fifths is the imaginary part. So negative 12 fifths plus 4 fifths I. All right, now let's take a look at the final two. These will go pretty quickly. Okay. Number 4. We're looking for the real part of this complex number, which happens to be x minus iy quantity squared. So that is equal to the real part of, let's FOIL this out in our heads, x squared minus 2xyi, right? If you multiply that together, you get negative ixy, or xyi. Two of them would give you negative 2xyi. That's the outer and inner added together. And then we have plus iy quantity squared, which is I squared y squared. Okay, so notice that this is a real number. Why is it a real number? Because I squared is a negative 1. So this is just a negative y squared. And this is x squared. That's a real number. This is the only imaginary part. So we are going to get, maybe I'll go ahead and write it out, x squared minus y squared minus 2xyi. This is the real part of the complex number. This would be the imaginary part because it's being multiplied by I. So the real part is x squared minus y squared. Okay, let's go on to the last one of this video. Number 5, the real part of x plus iy times x minus yi. All right, well that is equal to the real part of, all we have to do is FOIL this out, get an x squared. Notice these are a complex conjugate pair. So the outer and inner cancel out. And when you multiply the last, you get iy times negative iy, you're going to get a positive y squared. So in essence, we are taking the real part of a real number. There is no imaginary part in this number, and I doesn't show up anywhere. So the real part of that is x squared plus y squared.